Trailing zeros and 0 at the end of the measurement are the bane of everybody's existence when it comes to significant digits and significant figures. So, to give you an example of that, I went in and erased the wood to try to make it spot on exactly at 60 so that we would have 0 at the end of the number. You might have to use your imagination a little bit. I was freehanding it. So we're going to pretend this piece of wood is actually 60.000 forever. But we don't know that when we're measuring it. We just want them to all be identical and exactly 60. So taking our 3 rulers of the same ones and looking at what we need to measure now that it is a little bit shorter. I've cut some of the wood off. Let's take our measurement here. And again, it's measured out to 100 millimeters. And I'm going to have to guess, and different people are going to guess different things. Since last time I said it was 60, I'm going to try to be consistent with that. So here, I'm going to guess, I have my hundreds place, my tens place, my ones place, and so on. So what do I think goes in the hundreds place? It is bigger than 0. It is smaller than 100. So in that place, I'm going to write 0. It's on the left, so that's not significant. Now, is the next digit, is it 0? Is it 100? No, it's not either or. It's not either 0 or 100. I can guess in between those two markings, and I have to. That's going to be my one significant digit here. So if I didn't know it was 6 from before, would I pick 6? Maybe, maybe not. Some people might do 7, 8. Doesn't matter. That is the last significant digit, and everybody knows it's a guess, right? And so we need a placeholder. That is not significant. Remember, to get that represented better, I'm going to write that in scientific notation. I've been working in centimeters, so that's millimeters. So looking at the one down from that, I got 60 last time for that number because it wasn't marked to anything else. Here it is, and so I'm saying this is right on the line. So let me look at this variation. I'm going to do the same thing. See how far I can measure. Okay, so has anything changed in the hundreds place? No. I'm pretty sure that's 0 still. I'm getting more certain because I have more markings. It is definitely, probably, between the, 6 for this one. Sometimes you will have this drop down and go, well, I think it's 5'9", and that's okay. Sometimes the estimation's going to change that, but for the most part, we're going to get the same thing every time from where it's marked off. Okay, now the last digit. Even though it's on the line, sometimes people just want to drop the 0 and you can't. I have to say, not because of place value, but because of confidence, the last digit has to be a guess. And so I am estimating that this is right on the line at 0. Okay, so these look like the same numbers, but they have different levels of confidence. That means if I write this out in scientific notation, I can't drop the 0. But I did it. I'm not supposed to. I would keep that 0. And so I would do 6.0 times 10 to the 1 millimeters. So that's how these would be different. I'm using 2 different instruments. I'm getting about the same thing. But when I write them out in scientific notation, you can really see the difference in significant digits. The top one has 1 significant figure here, and then the bottom one has 2. I cannot drop that 0. And I cannot just say on the second one that it's 6 times 10 to the 1, because that would make people think that I had measured this to get that number. While we generally don't care what people think, in this case, we need to convey our confidence to the reader, and so we have to give them 2 significant figures so that they know that we measured with a more precise instrument. If we go to the bottom one, I've added another level of confidence. So for my hundreds place, I still know that that's 0. I am going to say this is 6. If it's right on the line, I mean, I'm going to say it's 0. Okay. And then different people are going to get different estimates on whether it is dead on the line or not. I'm going to say it is, and then that would be 0. Even if you guessed like 59.99, excuse me, 59.9, we would still consider, even though the digit would actually change, we would still have the 3 significant figures. So here, those 3 are significant. If I want to write that in scientific notation, again, I can't just start dropping those zeros, because it would indicate the wrong level of confidence. It would say that I was guessing when I wasn't. I measured these. I know, more or less, that this is 6. I know that this is 0. And then I guessed that this was 0. I don't know. So that means when I go to write this in scientific notation, I have to keep those. They're significant. They can't just go away. Would the value of the number change if I drop them? No. The values for all 3 of these measurements are pretty much the same, but the levels of confidence are different. That's what those zeros are. They're the level of confidence. And so again, it doesn't mean they're not important. The significant here does not mean important. It means significant to the level of precision. It means here is what I knew. And when you go to make calculations with these, that's why you have to learn all of that in lecture about how many significant figures does my answer need. Because if you use a better ruler to make the measurements and then you drop zeros in your calculations, then you're losing a level of confidence that you want to preserve. Or if you get in your calculator and you start just adding zeros all over the place. Okay, I like zeros. I'm going to show off. I'm just going to put them everywhere in my answer. Then you are indicating that you have an even better ruler with a whole bunch more precision than you have. And so that's where significant digits are coming from. That's what we mean when we say significant. It doesn't mean important, and it doesn't mean holding place value. The zeros holding place value and the zeros holding a confidence level are 2 different things. Sometimes they're pulling double duty, and you have a 0 that is holding place value but is also significant to the level of confidence. And the best thing you can do to clarify that is to put it in scientific notation so that it's absolutely clear to the observer that this 0 is significant. The scientific notation takes away the need to hold place value, because that 10 times 10 to the whatever, that's your place value. And the 0 doesn't have to hold the place value anymore. And so it is just, if it's there, it is significant. If it's not there, it is not significant. And to make absolutely sure you understand this, I only mean that with regard to trailing zeros. There are different rules. Let's say if we had 0.06, I'm only talking about the ones to the right. There are different rules that you'd have to go in. Like, these are never significant. These are always significant. The scientific notation helps you deal with what are called trailing zeros, which are the ones to the right of the last non-zero digit. And again, cannot recommend scientific notation enough. Use it if you're in doubt as to how many sig figs you should have.